What is the process execution cycle? A process has its own life cycle or execution cycle, as it can be in different situation or state. This called the process state. The process after creation until termination go through various state. There are 5 main states in process life cycle. First is new. Next is ready. Next is running. Then wait. And last termination. This called process state transition diagram. First state is new. When a process is created, it's in a new state. For example, when you open a program in your computer, the program code which is saved in the second memory picked up to the main memory by the operation system. At that time, after the process picked up to the RAM, the state changes to ready. The process structure and process control block is created in the new state. We can say that a process is in ready state when it is loaded into the RAM and waiting for the CPU to assign it for execution. After waiting for some time in ready queue, the process will be scheduled for execution. When the CPU start executing the process, at that time the process turns to running state, where the CPU will execute line by line the executable code. A process is executed for particular time quantum as the CPU can execute only one process at a time. When a process is being executed by the CPU and a high priority process comes in main memory or ready queue, CPU will give importance to the high priority process, so it will stop executing our process and start the execution of the high priority process. At that time the state changes from running state to ready state. Another thing that can happen while the process is in the running state is, it can require some input or output operation. CPU cannot wait till that time, so the CPU stops the execution and process goes to waiting state where it will complete the output or input operation. After completing the input-output operation, the process goes to ready state. Another thing that can happen while the process is in the running state is that the CPU will completely execute the process. It will execute the complete executable code and the process will get out of the main memory, and the process goes to the termination state. When we are in the termination state, the process structure and process control block will be deleted. Now we will talk about the process scheduling. You might heard about it while talking about different states of process. The process scheduling is an algorithm that choose a process between processes that is in ready queue to be executed in the CPU. The objective of process scheduling is to have process running all times, to maximize CPU utilization. In order to help with this process scheduling, we have something known as scheduling queues. There are 2 kinds of queues, which are the job queue and the ready queue. The job queue consists of all process in the system, so when a process enters the system they put in a queue known as the job queue. The next queue is known as the ready queue. The processes that are residing in the main memory and ready and waiting for execution are kept in a list called ready queue. This diagram shows what happened to the process when it goes from ready queue to running state. First, the process comes from the job queue to the ready queue. The process waits with the other processes in the ready queue until the CPU assign it for execution. Once it gets to CPU and it begins the execution, there are several cases can occur. The first thing that can happen is that the CPU complete the full execution of the process and the process ends. Another thing that could happen is that it comes from the ready queue and assigned in the CPU for execution, and at the same time a high priority process comes to the ready queue. So the process that was executing it will get swapped out and it goes to executed swapped out processes queue. After that it gets swapped into the ready queue and wait to be assigned again. Another thing that can happen that a process from the ready queue is assigned for execution in the CPU, and in some time the process need a input-output operations, so the process goes to waiting queue. And if the input-output device is available, that operation occur. If it's not available, it waits in the queue until the device is available. After that, the process goes to ready queue and waits for execution.